Example 3, write equations given characteristics. So we want to write an equation for hyperbola with foci 1, -5, and 1, 1, and a transverse axis length of 4 units. The first thing we must need to know is that transverse axis means it's kind of like the major axis from ellipses. So this is going to be representing 2a. So 2a here equals 4. With that being the case, that means that a equals 2, and later on, a squared will equal 4. Now I'll start with these points. So it says graph with foci located, and I'm going to make mine a little bit more like this, just because I'm going to have a point way down low. So it says go right 1 and down 5 units, 1, 2, 3, 4, and 5, and place a foci there. And we also have a foci at 1, 1. Now remember, these are going to be within the hyperbola, so this must be a vertical hyperbola. What that means for me is that I can put the y first, and what I'll call the shell of my equation. So I have this, I can put the y first. Not only that, we can determine the center from this. These foci, it look like, are about 6 units apart, because this one's down 5, this one's up 1. If they're 6 apart, then the center is located 3 units each way. So what that means is our c is going to equal plus or minus 3, which means c squared will equal 9. We'll need that in a little bit as well, so I'll just put that on the side. So our center is here. Well, now that I know my center, I can say, oh, this is shifted down 2 units. So I should put a plus 2 there, and I need to put a minus 1 to shift it right 1. Now we already know what a squared is. It's 4. A squared goes under the positive, so it goes there. All I need to find now is b squared. The way to determine b squared is we use the formula c squared equals a squared minus b squared. Now c squared we know is 9, and that'll equal a squared, which is 4. Now here's what's tricky, is we need to remember this b squared is technically going to be a negative b squared, which is going to turn this equation, when we plug it in, it'll actually turn it positive. So this is where you're just going to need to remember that this is going to be a negative b. So you can either do it that way, or you can leave it as negative b squared like this, but when you subtract the 4 over, we're going to get 5 equals negative b squared, which is the same thing as b squared equaling negative 5. I know this is bad math, but we're going to say the negative's already there. All we have to do is put the 5 there. That's going to be our equation. And we're done. That's all that's required. Now, if you wanted to graph it, we could. We just know, okay, you would know how far up the vertex is. You'd take the square root of this. So it'd be plus or minus 2. So I'd go up 2, and I'd have a vertex there. I'd go down 2. I'd have a vertex there. To know how wide the hyperbola is, you would take the square root of 5, which is about 2.4 something. So you go 2.4 units this way, and you put a dot, 2 this way, 1, 2, 3, and so you would have a dot over here, and then you would do the same thing, dot here. Oops, that's across from the foci. It needs to be across from the vertex. There and there. And then you would just plot your asymptotes. And after you plot your asymptotes, you should be able to draw a nice looking hyperbola. So this hyperbola would go up from these vertices this way, like this, and like that. And the only other piece of information that I did not include on this would be the asymptotes. And remember, those would be found by going y equals plus or minus. You do rise over run for your slope. So the rise is the square root of 4, which is 2, over the square root of 5, x plus b. Now, when you would simplify that, we would get y equals plus or minus. Remember, we have to rationalize 2 square roots of 5 over 5x plus b. But that you could use this and plug in the center point of being right 1, down 2. You can plug that in there and there, positive 1 here, a negative 2, and solve for your 2 b's. That's how you do that. But all that is just extra. I was just kind of walking through it. Let's look at part B. It says, write an equation for hyperbola given this information, and this time it says a conjugate axis. Now this is like your minor axis. This means this is like 2b. In this case, 2b equals 6, which means b equals 3, and so b squared will equal 9. So now let's go ahead and plot this graph. Looks like left 3 up 10, which since I'm left 3 up 10, I'm going to draw it a little bit more like this. So left 3 up 10 units, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there is a vertice there, and then the other vertice is left 3 down 2. There's my other vertice. Well, at this point, the vertices are my A value, and I can also find the center. This one was up 10, this one's down, no, it's supposed to be down 2. I put it down 3. I'm sorry. Let me fix that. Oh, can't fix it that way. Let's just plot it. There we go. They're 12 units apart, down 2 and up 10. So since they're 12 units apart, the center is 6 units away from each. So that center would be located there. There's my center. And those are 6 units apart. So my A must be 6. And if A is 6, A squared equals 36. In the center, we're saying is left 3, up 4. Now let's write the equation. What do we know? Well, we always have a parenthesis squared minus another parenthesis squared, each over some value, and that's going to equal 1. Since this is vertical, these are vertices, the y must come first, so we'll have a y there, an x there. And we also know that it's shifted left 3, which would be a plus 3, and up 4, which is a negative 4, because everything's opposite. We have already determined a squared is 36, and we've now determined here the b is the 9. So we put that there, and this is our answer. Again, if you wanted to graph, you already had the vertices. You would go left and right 3 units, draw your asymptotes, and your hyperbola would come from there. Here's one for you to try.